Hi, we'll talk about portfolio management, multifactor models. It's a pretty straightforward reading, so I'm not going to be following word by word. I just have three very broad things here which I'll just cover. Three assumptions, which is kind of important. First is unsystematic risk can be diversified. You cannot diversify the risk of being in the market, but you can diversify the risk every single security holds by diversifying your portfolio. Second is no arbitrage opportunities exist. So the APT model has these assumptions. The APT model says that whenever there's an arbitrage opportunity in the market, the investors are going to invest so heavily in it that the prices would immediately go towards their equilibrium. Third is returns are generated using factor models. Basically, it's telling that the models work. Okay, then the next thing we have here is the APT equation itself, which is very simply the risk-free rate plus beta of whatever factor into, this would be the sensitivity, this would be the abnormal returns, yeah, plus beta of factor 2, whatever the sensitivity of this stock is, into whatever the abnormal returns this is giving. And so moving to, yeah, so you'll see some numericals like this where there would be three portfolios, there would be expected return, then there would be factor sensitivity. Okay, so expected return, for example, I'm taking an example from Schweizer's here. So the whole idea is that you're going to find whatever portfolio is giving you the worst kind of return per unit of factor sensitivity. So that is simply, if you want to understand in very plain terms, it would be per unit of risk that I'm taking, what is my return, and you're going to be choosing the worst one to short and the two better ones to long. So how am I going to find what is the, how good or bad the returns are? So I would simply divide my returns by whatever my factor sensitivity is. Okay, what's 13 divided by 1.5? So I know that per unit of risk that I'm taking, the returns are these, and this of course is not a very great return that I'm getting. So I'm going to short C and long A and B. Now the question is, what would be my weights? How would A and B be divided amongst my portfolio? So the answer is, we have to form a portfolio of these two in a way that our beta is going to be this. So how my beta is going to be this is weight 1, that is how much I'm going to buy A stock and or A portfolio. So 1 into 0.1 plus 1 minus weight 1 into 0.2 is equal to 1.5. I want the beta to become equal to this. I want the risk that I'll be taking in both of these to be equal to this, and we'll see later why. So a shortcut for these are you do something like 1 to 1.5. Okay, and what you do is 2 minus 1.5 is 0.5, 1 minus 1.5 is 0.5, and that is how I'm going to divide my portfolios. Mm. Okay. So I'll be buying 50% of A, like I'll be putting 50% of my money in A, 50% in B. So let's see what my returns are going to be. So it's going to be 50% into 10%. So that's going to be 15%, and my beta is going to be 1.5. So for 1.5 of beta, I was earlier getting a 13% return, but now after this I'm getting a 15% return. Now what I'm going to do is I am going to long A and B and short C. So what I'm going to do is I am not going to invest any of my money. Whatever my proceeds from short are would go into long, and I would have a net return of 2% without any investment and without taking any additional risk, because my risk is uh, what do you say, squared off. So this is what ABD talks about. It says that opportunities like this is not it's not practical for them to exist, because the investors would exploit it and immediately the prices would adjust to the equilibrium. Moving forward, we have some numericals that are very simple actually. So let's just solve it together. An investment firm employs two-factor equity model. The risk-free rate is 5%, and I have to find out expected return for a fund where there are two factors. These are the betas, these are the risk premiums. Okay, it's as simple as it gets. Honestly, I'm not even sure if something this simple would show up in the exam. I'll be very happy if it does. So what would be your expected return? Your expected return is going to be the RFR plus this into this plus 2 into 0.15. Okay, that is going to be my expected return, which would be 12%. Now next is okay, so in the next one what they've done is they have basic linear calculation. What's happening is I have a portfolio AB. I have two portfolios, A and B. Expected returns are 7%, 7.8%, and factor sensitivities. This is beta, okay? 1, 1.2. Don't let the word factor sensitivity throw you off your game, because it's nothing but beta. You should just, freeze it in your brain that whenever it says factor sensitivity, it's beta, what they're talking about. All right, so it says that what do I have to find out? Hmm. Calculate the risk free rate and factor risk premium. Okay, so this is my expected return. Okay, I'm going to be building a very simple equation. So RFR plus 1, that's my factor sensitivity, whatever my risk premium is. Okay, and then 7.8, the same equation for second portfolio. This would be the factor sensitivity. Risk premium for one factor is going to be the same across any number of portfolios, because that's the risk premium. What's going to differ is the factor sensitivity. Yeah, so now we have I can simply subtract this. So we have minus 0.8, RFR is cancelled. Then we have minus 0.2 RP, 0.8 into 0.2 is equal to 4. That's going to be my risk premium. My risk premium is 4%. Now substituting it here, I know that my RFR is 3%. Very simple, class 10, I believe, mathematics, right? Okay, so there's a second part to this question where it says verify that portfolio C with an expected return of 6.2% and factor sensitivity of 0.8 is priced correctly. So beta is 0.8, risk premium is okay, I don't know what risk premium is. Expected return is 6.2%. I know from my previous example, from my previous solution, alpha is 3%, and the risk premium is 4% for this factor. Now let's plug everything and see if this is correct. 3 plus 0.8 into 4, so that's going to be 6.2%, 6.2, so it is correctly priced. I move to the module quiz, where in question number 2 it has a similar numerical like we just did. Okay, so per unit of risk, what am I getting? Let me grab my phone. I am really bad at calculations, so I have no luck without my phone or a calculator. So we're going to be shorting the third one, and we'll go long on these two. Okay, it did not ask us to find out the weights, but just for the sake of learning. Yeah, I don't know why it cut me off. So yeah, I was saying for the sake of learning, let's still calculate the weights. So we're going to do a very simple way. 1.22 and my target is 1.76. This is 0.24, 0.56. Let me just verify that very quickly. Yeah. So this comes out to be 30%, 70%. Now be very careful. 30% of this, 70% of this. So I'm going to take 30% of A, 70% of P. Okay, let's read the next example. Okay, module quiz 4.1, question 3, very simple question. RFR is given, there are factor sensitivities that I know, and there are risk premiums that I know. I'll calculate it quickly because I'm awful at calculations. But you know what? I'm good at Excel, so I kind of make up for it. So that would be option B.